So in this lecture, we are going to cover the functions and attributes of embedded systems. After having understood what are embedded systems, how can we try to create an application or implement an embedded system. So what are basically the functions or attributes of embedded systems? Size of the processor is reduced. We have already seen this, and the possibility for the portable products has increased considerably. So this is one of the attribute of embedded systems as we discussed, its portability, right? Besides, we can also look at these points. Embedded processors reduce the number of electronic components in the application design and prove to be efficient in performance and reliability. Obviously, since embedded processors are focused on a specific application, our overall hardware size reduces and it is more reliable and much more efficient as compared to your general purpose systems. The cost of an embedded processor is also reduced, but its performance as well as the number of peripherals inside the chip has increased now. So in the modern microcontrollers, in the modern embedded systems, the cost is less, but the number of peripherals in the chip are more. We'll cover some of the peripherals in this lecture. Hence, the cost and time required to design and develop the product is also reduced. Power consumption of the processor is also reduced, and hence most of the embedded systems are now battery operated or they require less power as opposed to your general purpose systems like laptop and desktop PCs. Increased number of efficient hardware and software development tools as well as testing edge measurement tools facilitate completely bug-free products. So as we saw in the previous lecture also, the complete design cycle of an embedded system or a product, that is an embedded product. So now we have a lot of tools for emulation, for testing, for debugging, so that our end product is almost bug free. It is not having any bugs and it is running as per expectations. Now coming to some of the features of the embedded systems. Usually every embedded system or microcontroller is going to have these peripherals. So there can be a variety of peripherals when we talk about an embedded system or a microcontroller. So we can start with a DMA controller, DMA control, direct memory access. ये हमने पहले भी पढ़ा है. It's a peripheral device that helps to perform data transfers directly with the memory without the involvement of CPU. Right? So यहाँ पे CPU का कोई रोल नहीं रहता है and memory transfers can happen directly. Then we have AD converter, analog to digital converter, which will convert analog signals into digital information for further processing. Some microcontrollers can have more than one AD converters as well with different resolution. So जब हम MSP 430 का ब्लॉक डायग्राम पढ़ रहे थे तो मैंने थोड़ा सा रेजोल्यूशन डिस्कस किया था. So रेजोल्यूशन मीनिंग कि आपका जो AD कन्वर्टर है कितने बिट्स तक, कितने मैक्सिमम बिट्स तक रिजल्ट दे सकता है. 10 बिट, 12 बिट, 16 बिट, 32 बिट etc. We have power management control also, which powers up or powers down operations as and when necessary for the processor in order to save power, reduce the power consumption. Capture compare units are available that compare the timer values with a set value by the application. Whenever both the values are equal, it triggers an event. So we have done capture compare unit in detail in unit 1 when we were studying PCA timer. So you can refer to the lecture if you want to know more about capture compare modules. DA converter is the digital to analog converter, exact opposite of ADC, that converts the processed digital information into analog as required to drive any device or display. Cryptography accelerator is used to generate random numbers, hashing and supports for network security. तो आजकल security बहुत ही important हो गई है. So in many embedded systems and microcontrollers, you also find this module to enhance the network security. USART is the universal synchronous asynchronous receiver transmitter, which reduces the external hardware interface and supports for serial data transmission. ये भी हम लोगों ने यूनिट 1 में थोड़ा डिटेल में देखा हुआ है. Timer is a peripheral that is there in almost all microcontrollers, and it is used to generate time delays, and it can also act as an event counter. Ethernet port reduces hardware complexity and supports network-based communications like internet and intranet-oriented data transfer. Then we have IRDA transceiver that supports short distance communication. This is based on infrared communication. RTC or real-time clock, it helps to monitor the clock events that need to be controlled. So it is slightly different from timer in the sense that it tracks the time in conventional sense, in real-time sense, like in the ways of minutes, seconds, hours, days, weeks, etc. Multiply accumulator circuit is also available nowadays, which facilitates fast multiplication of data, and multiplication can also be followed by adding or summing. PWM is the pulse width modulation channel, whose pulse width can be varied to execute various applications such as motor control, audio generation, etc. So pulse width module भी हमारा available रहता है. This also we have covered in unit 1. JTAG Joint Test Action Group, ये भी हम लोगों ने पहले पढ़ा हुआ है. It is an interface that provides support for programming and debugging the processes. So in MSP 430 also this is available for programming. Filters may be available in your embedded system, and they can be either high pass or low pass, and accordingly they will be filtering the high frequencies or the low frequency signals respectively as and when required for the applications. Switch mode pump is a boost converter used for voltage conversion, that is from low voltage to high voltage. SPI is again a serial communication protocol which supports for serial communication. Then we have periodic interrupt controller, which is an important peripheral to control all the interrupts related to a microcontroller on an embedded system. So the interrupts can also be present to attend to an emergency request. USB or universal serial bus supports multiple device access. So आजकल काफी microcontroller embedded systems में ये support available रहता है, so it can be directly connected to the PC, either for downloading the program, for debugging, or just observing the results. Phase lock loop PLL is also present, and it is a clock source for different peripherals. So आपका एक frequency oscillator present रहता है microcontroller में, and using PLL you can modify those default frequencies into some other frequencies as and when required by the peripherals. I2C again, this also we have studied in detail. Two-wire protocol that supports serial communication, and processor uses it to communicate with different number of external peripherals. Spectrum spreader is an important peripheral that reduces EMI problem that must be reduced for final product certification. So electromagnetic interference. So this is usually that is ignored or neglected by developers and designers, but this is very important. When you are having different peripherals, then EMI is necessary. That means reduction of the total EMI is essential. Then only the final product certification can occur. Clock doubler allows the user to use a crystal oscillator which can produce half the value of frequency required for normal operation, since it doubles it internally. This feature helps in reducing power consumption and radiated emission. Memories can be of different types. This also we have seen earlier, like flash ROM, SRAM, EEPROM, etc. for different purposes depending on whether you have to store volatile data or permanent data. So these were some of the features and attributes and functions of embedded systems.